Now that we have the ability to measure how far 2 points are in a coordinate system, we could use that to derive the equation of a circle. And I'm sure this equation should be reviewed. Some of you may have forgotten it, but still, you've seen this equation before. But let's be explicit of where it comes from, that it is deeply or directly rooted in the distance formula. So if I have a circle, say, as drawn here, and it's, say, at the point, we're going to be generic, so we're just going to call it the center of the circle is the coordinate A, B. And all circles really are the set of points equidistant from the center. Again, a circle, so the boundary of this circle all the way around should be all the points. Let's just give this a generic point, and again, call it x, y. And the point xy should be on the circle if its distance from AB is r. Well, from the last section, we saw that the equation for distance is the square root of the change in x. So this is our first x coordinate. This is our second x coordinate. So it'd be that distance squared plus that distance squared. So we know from previous that r, right, that's this distance, AB to xy. That distance is r. And it, from the distance formula from the previous section, has to be equal to x minus a squared plus y minus b squared. And that's actually a perfectly good equation of a circle, though not the one we normally see. Typically, when we talk about a circle, we'll square both sides, and really it reflects Pythagorean's identity in that r squared has to be equal to x minus a squared plus y minus b squared. Oops. So this is the general equation of a circle with radius r centered at the point AB. X, y are the set of points on the boundary of the circle that satisfy the equation. So let's look at some examples. So if I wanted a circle, so a circle centered at say the point 1, 3 with radius I don't know, 2, then the equation, so if I want a circle, the equation of a circle centered at the point 1, 3 with radius 2, then it would be, the equation would be x minus 1 squared plus y minus 3 equals 4. This is our radius squared. This is our x coordinate here for the center. So x value of center. And this is our y value of center. So just using our formula that we derived in the previous section, right, that we have r squared, radius squared, plus equals x minus whatever the x value of the coordinate of the center is, squared, plus y minus whatever the coordinate of the value of the y coordinate is, squared. So that's all we did. We filled in the blanks. Our center was 1, 3. We have radius 2. So our equation is simply x minus 1 squared plus y minus 3 squared equals 4. I might also say take a problem like this and say, well, so another way we can find Equations for circles would be given some algebraic equation and trying to determine yes or no, is it a circle? So let's look at an example. Say I've got x squared plus 2x plus y squared minus 2y minus 4 equals 0. Now, on first blush, this doesn't look like the equation of a circle. We saw before, equations of circles look like we've got x minus something quantity squared plus y minus b quantity squared is some constant squared. But that doesn't mean that maybe these terms have been factored out and terms have been collected, and so this still may be the equation of a circle. We'll just have to run a little bit of algebra on it, and so this is a great place to remind ourselves how to complete the square. Because really I want to collect all my x terms and add something, so this looks like x minus a squared. And I want to collect all my y terms and add something, so this looks like y minus b squared. And that's exactly what completing the square does for us. So if you recall, if I complete the square, I take the term in front of x, divide it by 2, and square it. So this equation can be rewritten as x squared plus 2x plus, and you take that same term and divide by 2, which of course is 1, and square it. I'm going to do the same. I'm going to, over here, I've got a 0. And now, to keep the equation balanced, if I added, this expression here is really just 1. So if I'm going to add 1 over here, to keep the equation balanced, I'm going to have to add 1 over here. I'm going to do the same thing with the y, so it's going to be plus y squared minus 2y plus, and that'll be negative 2 over 2 squared. Now, negative 2 divided by 2 is negative 1. Squaring it gives me 1, so I'm going to add 1 again, and I still have this minus 4. And so finally, well, let me just rewrite this. So I've got x squared plus 2x plus 1 plus y squared minus 2y plus 1 minus 4 equals 2. Now the whole reason I went through and did this completing the square, is because now this whole expression is, so x squared plus 2x plus 1 is exactly the form of a perfect square. So this factors into x plus 1 squared. And then I got y squared minus 2y plus 1. Again, this is factors into a perfect square. So I get y minus 1 squared. And then I still have a minus 4 equals 2. And so much closer. So finally I can say, oh, well, this is x plus 1 squared plus y minus 1 squared. And if I bring the 4 over, this is 6. And now this is exactly the form. I've got x plus, so what's my center here? It's going to be negative 1 for the x-coordinate. Over here, the center is positive 1 for the y-coordinate. And my radius squared is 6. So looking at this equation, I now know that this is the equation of a circle. So the circle has center. The x-coordinate is minus 1. The y-coordinate is 1, and radius square root of 6. Okay, so that's the equation of our circle that we had. Oops. Whoa. The equation of our circle, because we took this equation, x squared plus 2x plus y squared minus 2y minus 4 is 0, completed the square, and we can see that it's a circle of radius root 6 and centered at 1, 1.